Hi, in this numerical, they ask about dissociation of phosphorus pentachloride, and the information is provided here that phosphorus pentachloride is 41.7% dissociated at 453 Kelvin under 1 bar pressure. Then we need to calculate Kp for this. Then we need to calculate the degree of dissociation at 2 bar. So this is the problem. So phosphorus pentachloride is 41.7% dissociated at 453 Kelvin under 1 bar pressure. Calculate Kp for the reaction and then calculate degree of dissociation, that's alpha, at 2 bar pressure. So consider dissociation of phosphorus pentachloride. I'll write equation here. So answer for this. First write chemical equation for dissociation of phosphorus pentachloride PCl5 gas. It dissociates and gives PCl3 phosphorus trichloride gas and chlorine gas. So get these two gases. Now I'll write here initial moles. Suppose initially there is 1 mole of PCl5. Initially there won't be any product. So number of moles for PCl3 will be 0. Number of moles for chlorine is also 0. Then I'll write moles at equilibrium. Now consider its degree of dissociation is alpha. Then alpha moles of PCl5 gets dissociated. Since here 1 PCl5, 1 mole of PCl5 gives you 1 mole of PCl3 and 1 mole of chlorine, alpha moles of PCl5 gives you alpha moles of PCl3 and alpha moles of chlorine. So number of moles of PCl5 remains here will be 1 minus alpha. Then calculate mole fraction. So for calculating mole fraction, you require total number of moles at equilibrium. So I'll write here total number of moles at equilibrium is equal to sum of number of moles of PCl5, that is 1 minus alpha, plus number of moles of PCl3, that's alpha, plus number of moles of chlorine, alpha. So this gives me answer 1 plus alpha. So mole fraction is equal to number of moles of PCl5, that is 1 minus alpha, divided by total number of moles at equilibrium. So that's a 1 plus alpha. Similarly, mole fraction for PCl3 will be alpha divided by 1 plus alpha. Mole fraction for chlorine will be alpha divided by 1 plus alpha. Then I'll calculate partial pressure at equilibrium. Partial pressure at equilibrium. So that's equal to 1 minus alpha upon 1 plus alpha, that is mole fraction of PCl5 into total pressure, P. Here P is a total pressure. Now mole fraction for PCl3 will be alpha divided by 1 plus alpha into P. Similarly, partial pressure for chlorine gas will be alpha divided by 1 plus alpha into P. Now write equation for Kp. So Kp is equal to partial pressure of products divided by partial pressure of reactant. So here there are two products, that is PCl3. So it is a partial pressure of PCl3 into partial pressure of chlorine divided by partial pressure of PCl5. So put these values here. So what you will get here? Partial pressure of PCl3 is alpha divided by 1 plus alpha P. Partial pressure of chlorine is again alpha divided by 1 plus alpha into P divided by partial pressure of PCl5, which is 1 minus alpha divided by 1 plus alpha into P. So this PP get cancelled here and we'll get equation alpha square P divided by 1 plus alpha into 1 minus alpha. Okay, now this P indicates total pressure which is given here. The total pressure is 1 bar pressure. Kp value we need to find out. Alpha is given here. This is a percentage alpha. So your percentage alpha is 41.7%. Therefore, alpha is equal to 41.7 divided by 100. So it gives value 0.417. Put this value of alpha here. So we know alpha, we know P. So we can easily calculate Kp here. So I'll write this again here. Kp is equal to alpha square P divided by 1 plus alpha 1 minus alpha. So Kp is equal to, now we know about alpha. What's the value of alpha here? 0.417. So it's a 0.417 square. What's the value of P? That's the total pressure. Is given 1 bar. 1 plus alpha 1 minus alpha, I can write 1 minus alpha square. So this gives me Kp is equal to 0.41 square, 0.417 square divided by 1 minus 0.417 square. So this value will come here 0.21. Now this Kp will remain constant. If you change the temperature, then only Kp can get changed. Otherwise it remains constant. So Kp is a constant here. Now suppose total pressure P total is 2 bar. Then what will be the value of alpha? That's the next question. So in order to solve this, we have this equation, that is Kp is equal to alpha square P divided by 1 plus alpha 1 minus alpha. This value of Kp we already find out here. So we already got this Kp value. So put this Kp value here. So it's a 0.21 is equal to alpha square. This P is 2 bar. So 1 minus alpha square. So by solving this, we get alpha square is equal to 0.21 divided by 2.21, and that's equal to 0.095. So alpha is equal to square root of this value 0.095. It will come 0.308. So what's the percentage alpha in this case? The answer is 30.8%. So percentage dissociation for PCl5 will be 30.8% at 2 bar pressure. So in this case, if you increase pressure, then dissociation is decreasing. That means less PCl5 is getting dissociated. So that's according to Le Chatelier principle. So here we completed this numerical. Thank you.